Observe the flight of a heavy projectile in motion. It follows a smooth, entirely predictable arc through the air. But when it explodes mid-flight, that order is suddenly replaced by chaotic shrapnel, spinning in thousands of random directions. Yet, inside that cloud of debris, there is a hidden mathematical anchor, the center of mass. Even as the fragments fly apart, look at that glowing center point. It continues along its original path, moving through the explosion as if nothing happened. A chemical blast generates massive physical force. Why didn't that force push the center of mass off its trajectory? The contrast between the wild behavior of the pieces and the steady path of the whole system reveals a core rule of mechanics that governs the entire physical world. The center point's position by taking the mass-weighted average of every fragment. Tracking these positions over time reveals the velocity and total momentum of every moving part. Measuring this velocity change gives the acceleration of every piece of metal. Following Newton's second law, we know these fragments only change speed because of physical forces pushing and pulling on them. We now have a mathematical blueprint of every force acting on the system, allowing us to find exactly what keeps that center point stable. We can simplify the problem by sorting every force on the board into two strict categories, internal and external. The external force here is gravity. It originates outside the shell and pulls downward on every piece of debris. The internal forces come from the explosion itself, the chemical energy causing fragments to push violently against one another. By Newton's third law, every internal push has an equal and opposite push back. These internal forces perfectly cancel out. Their sum is zero, leaving only gravity's downward pull. The math simplifies. The system's mass times its center's acceleration equals only the external forces. Because internal forces vanish, the center of mass is blind to the internal chaos. Its path is dictated exclusively by the outside world. If we look at the original explosion again, we can see the rule in action. The explosion was a purely internal force. That means it added exactly zero to the external side of our equation. Gravity was the only external force before the blast and the only external force after. There was no mathematical reason for the center of mass to change course. This same principle applies to any complex system, like a diver mid-flight. As the diver flips and tucks, his limbs are moving chaotically relative to his chest. But while his body contorts through internal forces, his center of mass follows a perfect, steady parabola. By tracking the center of mass, we see that even the most chaotic systems behave as if all their weight is focused on a single point, driven only by the forces of the world around it.